Hey guys, so welcome to my first video on this channel. This is also the first time I actually post a video after making and editing it. So yeah, I think it's kind of funny when this ever first video I post is about the subject I'm not really good at, like physics. But the reason I post it is because my grade, of course, is my school assignment. So yeah, let's get into our thing. Okay, so guys, now let's start with our first exercise, number 13. A fish starts to swim from the location vector r1 equals 10I minus 4j in a phase with its first velocity 4I plus 1j meter per second. After it swam for 20 seconds with unchanged acceleration, its velocity now is 20I minus 7j. So let's start with questions A. Uh, Identify the acceleration recipe. And B. Identify the dimension and the way of the acceleration vector compared to the x-axis, to the y-axis. If the fish still if the fish still remains its unchanged acceleration, then where will it be, and which way will it go at the time 25 seconds? Okay, so now let's start from the beginning. So the fish started from the origin vector r equals 10I minus 4j, and its velocity will be 4I plus j meter per second, of course. And at the time of 20 seconds, its velocity now is 20I minus 5j meter per second. The question 8 tells us to find out the components of the acceleration. So let's just go through with the formula instead. So vector A equals to delta V, do it up on the delta T, vector I, plus delta V on delta T, vector J. So the delta here, it means that the velocity from the after minus with the first. So it will be, and so it does apply time too. So it'll be 20 minus 4 and go with 20, 20 minus 0, vector E, plus minus 5 minus 1 and 20 minus 0, vector J. Here will become like 0.8 E minus 0.3J. So it's the exercise tells us to tell the components of the acceleration. That means 0.8 will be 0.8 meter per second square on the e axis, and 0 minus 0.3 meter per second on the j axis. Here you can get it. So let's go to now to question B, which tells us to identify the way and it's mentioned. So here we have the velocity here will be 0.8 as well, just like up there. And I really think that we should draw it out. Let's just draw it out. So 0.8 is vector A and this is J. So this is 0.8 and this is minus 0.3. So we're gonna build here is a triangle. Yes, a triangle. A triangle would be 0.8 and 0.3 here. So here will be 0.8 and so here's the angle that we need to look for. As you can see, at this point it means the acceleration will go this way. It goes this way down. See? So it goes on the same it lies on the same dimension and on the same way with vector the axis I. Okay, so and this angle because alpha, because tan alpha equals to minus 0.3 up in 0.8. So there we have it. The alpha we find is minus 26.6 degree. Here's the answer for question B. So let's go with question C. It says if the fish still remains its unchanged acceleration, then where will it be, and at what way will it go at the time of 25 seconds? So let's go back. At the time of 20 seconds, its velocity is 20I minus 5j. So we can see the connection here. That means the delta t will be 5 seconds. As we have in the questions A, the velocity A is 0.8 I minus 0.3 j. So here is the part where we need to get a little bit smart a bit. Then the second velocity we're looking for, the third, will require us to use this m plus with the acceleration, but we have to double it with the time of delta t, which means 20 plus 0.8. This one will multiply with 5 ai, and it plus minus 5 plus 2 negative 0.3 multiplied with 5 here in the vector j. So eventually it will be 24i minus 6.5j. See, here's the second velocity. So, and to answer the question, where will it be? So just draw it out. So example is for 24. Just example 24, and this is like minus 6.5. We connect it, and we build a triangle. This is 0.5, and this is 24. So we need to find the angle. This angle here, we call it beta. So tan beta equals to minus 6.5 up on 24. It comes out that the beta angle will be minus 15.2 degree. And that's it. That's all of the exercise 13. So let's now move on to exercise for 24. A firefighter stands from a building with distance of 20 meters. The water came from the faucets, create an angle of omega 145 degree to the ground. Its thrust velocity is 20 meter per second. Identify the height and where it's burning compare of the building compared to the ground. Okay, so now let's start. We have to draw it out. From here, the water process is spray the water. From here, it's go down. Here, this will be the distance. This will be the height. This will be the 45 degree. Well, the distance will be 20 meters. Well, at this exercise, we have to use a formula which is called the moving equations. It goes like this: x equal v0 multiply t multiplied to cos alpha 1, and y equal to v0 t multiplied with sine. But this we have to minus with gravity, because we are looking on this direction, so we have to minus this with the gravity. We have to minus with gravity, and so we just need to put all the numbers up. So x equal to 20 equals to v0, which is 22 as well, and t and cos of 45 degree, which means our t will be p squared t squared 2 or 2, and y equals to 20 multiply to square root 2 and sine of 45 degree minus 1 2 plus g here will be 10 and square root 2 will be square root 2 root and become 2 and it will become 10. So here is our height. Height will become 10. Thank you for your time for watching this first video of mine and stay cool.